Hey guys, today we are looking at graphing and solving quadratic inequalities. So no more equal sign, we're going to have a less than, greater than, less than or equal to, greater than or equal to. So if we are graphing or inequalities here, the first thing we're going to do is graph the parabola. But then think back to Algebra 1 when you were graphing lines. If you have just less than or greater than, it was a dotted line. If you had less than or equal to, greater than or equal to, it was a solid line. We also had to test a point, and then we shaded where it was true. This time, instead of shading above or below the line, we're going to shade inside or outside that parabola. So we have y is less than or equal to negative x squared plus 9. So to graph, you could just set up your table. So I know that my vertex is going to be 0, 9. And so I'm going to put negative 1, negative 2, 1, and 2. So if I put negative 1 in there, I get negative 1 squared is 1. But then it's negative, so 9 minus 1 is 8. And then I get negative 2 squared is positive 4, but there's a negative out front. So 9 minus 4 is 5. Using symmetry, this should also be 8 and 5. So since that is a less than or equal to, it's going to be a solid line. So 0, 9. And then negative 1, 8. Negative 2, 5. You want to take up most of the graph so that you can shade, and so I might even extend these even further so it goes all the way down the graph. So probably the easiest point for me to test would be to plug in a 0, 0 to see if that would be a true statement. So if I put a 0 in here, is 0 less than or equal to the opposite of 0 squared, which is still going to be 0 plus 9. So is 0 less than or equal to 9? Yes, it is. So that means this point is true, which means that everything inside here is true. Now I'm going to switch colors so that I can see this a little better. So x, y, first thing I notice is that it's a greater than, so when I draw my lines, they're going to be dash. And I'm going to use my opposite of b over 2a to find my vertex. So I get negative 5 over 2 times 1. So that's a negative 2.5, negative 5 over 2. So if I put that in, I get a negative 12.25. That's going to go a little bit below our graph, but that's okay. If I use then negative 2, I get negative 12, so negative 3 would also be negative 12 since it's a half away. And then negative 1 would be negative 10. And so then negative 4 would also be negative 10. So negative 1 is at negative 10. Negative 4 is at negative 10. Negative 2 is at negative 12. Negative 3 is at negative 12, and then negative 12.25. So I'm going to dash this, and you can come up with more points if you like. And again, make it go all the way up that graph. So I'm going to plug in the point 0, 0 and see what I get here. So 0 is greater than 0 squared is 0, plus 5 times 0 is 0, minus 6. Is 0 greater than negative 6? Yeah, it is. So my point 0, 0 is on the inside. So that means I'm going to shade the whole inside of this. But remember that in Algebra 1, our final answer wasn't just this. It was where the shading overlaps. So this green is actually the final answer here. So there's where our answer lies. Okay, so that was graphing quadratic inequalities. Now solving quadratic inequalities. We can do this through graphing is one method. So to graph, first find the zeros. Then we're going to sketch the zeros, determine whether it opens up or down. If the polygon is less than 0, we're going to shade below the axis. If it's greater than 0, we're going to shade above the axis, and we will have a solution set. So x squared minus 11x plus 5 is less than or equal to 0. So you could factor this. You could complete the square with this. You could solve by quadratic formula if you wanted. So if we do this, if I use quadratic formula, x equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. I get x equals 11 plus or minus 121 minus 20 is 101 over 2. So if I'm graphing this, I need to decide, is this going to open up or down? And since I have a positive a value, it should open up. If you plug this in your calculator, 11 plus radical 101 over 2 is about 10.5. 11 minus radical 101 over 2 is about 0.5. So I'm going to plot those two on here. Now it's opening up. And since it is less than, we are going to shade below the axis. So this is different than when we were graphing these. Since it's less than or equal to, I put these closed dots here because we're including them. So our final answer then is starting at that 0.5, or 11 minus radical 101 over 2, and it goes all the way to 11 plus radical 101 over 2, or about 10.5, and it's including those points. So this is your answer for that. What if it were greater than? Well, we have that same graph at 0.5 and 10.5. But if it's greater than, we're shading above here, and it goes up forever. So that means that it's true from negative infinity up to 11 minus radical 101 over 2. Since it's greater than, it's not included. We use our or, our union. And then it's also true from 11 plus radical 101 over 2 all the way up to positive infinity. Let's try another one of these. So if we're looking, oops. Okay, skipped over a slide. So if we are looking at this one, we have negative x squared minus 9x is less than negative 36. The first thing I want to do is make it 0 there. So I have negative x squared minus 9x is less than, or sorry, is plus 36 is less than 0. Now, since we have that negative, that tells us it's going upside down. But the other thing we could do is divide this whole thing by negative 1 to make life a little easier. So then x squared plus 9x minus 36. Anytime we divide by a negative, we flip that sign. So it's greater than, that would be a negative 0, but negative 0 is just 0 since we don't have a positive or negative. Now you could use quadratic formula. You could try to factor. So I'm going to try to factor this here. So I need two numbers that multiply to negative 36 and add up to positive 9. So that would be 12 and 3. And since I want them to be a positive 9, it's a positive 12 and a negative 3. So I have x squared plus 12x minus 3x minus 36 is less than or equal to 0. So if I take out x, then I have x plus 12. And I take out a minus 3, then I have x plus 12. So then I have x plus 12, x minus 3 is greater than 0. So that means I have x is negative 12 and x is 3 is where our zeros are going to be on this graph. So I'm going to have a 0 over here at negative 12, and I'm going to have a 0 over here at 3. Now, since I switched it around, we're looking at this, it's positive. And I want to know where it's greater than 0. And it's not including those zeros. So that means all the way back to negative infinity, it's still true. Up to negative 12, not including, or starting at positive 3 and going all the way to positive infinity. So that's your answer for this one. All right, let's try another method. Algebraically, find zeros, make a sign chart, place it on a number line, and test points to find the true regions. So I'm going to move over this 3. So I have 2x squared minus x minus 3 is greater than 0. I'm going to try to factor. So I need two numbers that will multiply to negative 6 and add up to negative 1. I get that negative 6 by multiplying that a value of 2. So 3 times 2, and if I wanted to add up to a negative 1, I need negative 3 positive 2. So I get 2x squared minus 3x plus 2x minus 3 is greater than 0. So then I can take an x out of this first one, and I get 2x minus 3. And then I can't take anything out of the second one, so I take out a 1, and I get 2x minus 3. So I get x plus 1, and I get 2x minus 3. So my zeros are going to be negative 1 and positive 3 over 2. So what I'm going to do is make a number line. And on my number line, negative 1 comes first, and then 3 halves. I have x plus 1 and I have 2x minus 3. And then we multiply those together to get our final result at these places. So we know those are zeros, but I want to know what's happening in between. So I'm going to pick some numbers that come at different points on this number line. So for instance, a number between -1 and 3/2. Probably the easiest one to pick would be 0. A number bigger than 3/2, well 3/2 is 1.5, so I'm going to pick 2. You could pick 10, 54, whatever you want to plug in there. And then a number smaller than -1, I'm going to pick, let's go -3. So now I'm going to fill in the answers here with signs. So -3 plus 1 is what I'm going to put down on my first one. So -3 plus 1 is -2. That's a negative answer. 2 times -3 is -6, minus 3 is -9. That's also a negative answer. I'm going to move over to my middle region here. 0 plus 1 is positive. That's a positive 1. 2 times 0 is 0 minus 3. That's a negative answer. 2 plus 1 is 3. That's a positive answer. 2 times 2 is 4 minus 3 is positive 1. That's a positive answer. Now, if I multiply, negative times negative is positive. Positive times negative will give you a negative. Positive times positive will give you a positive. So, when we're looking at this, we want to know where we are greater than 0. So we are greater than 0 where we're positive. So on our number line, that's where we're at -infinity all the way up to -1, or 0 value there. You know we don't include -infinity. Since it's just a greater than sign, not greater than or equal to, we also don't include -1. Then we look at our other side, and so 3/2 is our other 0, all the way up to positive infinity. So there's our answer for this one. All right, let's try another one here. So 3x squared plus 11x is less than or equal to 4. So I'm going to put everything over on one side. So 3x squared plus 11x minus 4 is less than or equal to 0. And then I need two numbers that multiply to -12 and add up to positive 11. So 12 and 1. But to be a -12 positive 11, I want a -1 there. So I have 3x squared plus 12x minus 1x minus 4 is less than or equal to 0. I can take out a 3x, and I'm left with x plus 4. And over here, I can take out a -1, and I'm left with x plus 4, less than or equal to 0. So then I have 3x minus 1, and I have x plus 4, less than or equal to 0. Okay, so I get x is 1/3, and x is -4 is our 0 value. So I'm going to put those on the number line. So -4 comes first, and then 1/3. And I have 3x minus 1, and I have x plus 4. And then I need to find the result. So something smaller than -4 would be -5. Something between -4 and 1/3, 0. Something bigger than 1/3, I'll keep it easy and I'll just do 1. So 3 times -5 minus 1. So that would be a negative. And then I'm -5 plus 4. That's also a negative. 3 times 0 minus 1, that's a negative. Then 0 plus 4, that's a positive. And then 3 times 1 minus 1, that's a positive. And 1 plus 4, that's a positive. So if I'm looking, I'm going to separate this out. Negative times negative gives me a positive. Negative times positive gives me a negative. Positive times positive gives me a positive. Okay, I'm going to go look back at the original problem. It wants to know where we are less than or equal to 0, which is right here. So that's the only region where this is going to be true, is in the middle. So that's between negative 4 and 1/3. Since it's or equal to, we include both negative 4 and positive 1/3. All right, so 2 different methods to solve that same thing. If you have questions, feel free to come in and see me. I'll see you in class.